Hi, I'm Yuenn. I would like to present the project title of IoT application for the development of home security systems. The content of this video will be shown as below. Introductions of project. According to the Crime Statistic Publication 2021 of Malaysian government, there are 14.9% of housebreaking and thief cases happen in Malaysia. With the research, 60% of burglars think that the presence of an alarm will cause them to seek an alternative target altogether. With the statistic, only 17% of households will be occupied the home security system. So in this project, the development of home security system with IoT application is being carried out. IoT is a system integrated computing device and mechanical and digital machine. The home security system is one of the systems that include the security hardware. So in this project, the system is worked on the several high security lock system, which are password and RFID. So in this project, the Arduino Mega is the microcontroller of this whole system, and it will interface with the ESP32 cam for the live streaming using the Wi-Fi features. In this project, we are contain two methods of unlocking. First is RFID technology, which is formed by the RFID reader and RFID tag. For the second method of unlocking is a digital lock system. It's using the 4x4 metric keypad. And we also have the alert system in this project. SIM900 address and module is used. Alert message will automatically send to the owner when the wrong password is entered 3 times. For the problem statement, the home security system acts an important tool for keeping our safety and security. With the rise of the IoT technology, now is the right time to develop or consummate home security system to decrease the rate of the housebreaking cases. Many burglars are familiar with the structure of the lock system to crack the latest security system. So, with a security system that contains multiple lock systems and the user can monitoring the surrounding situation from time to time with the live stream video features will decrease the rate of the housebreaking cases. Objective and scope. Objective. First, to design a home security system with a combination of survival and locking system. Next, to develop a system that includes the features of sending an alert message to a mobile phone. Last, to monitoring the system by live streaming video from a developed website. Scope. First, to a home security system is controlled using Arduino Mega and RFID as the security lock system of the door security system. Next, the notification of entering the wrong password and the unauthorized person entering is controlled by Arduino Mega and SIM900 GSM module. The last streaming video is controlled by the Arduino Mega and the ESP32 cam with the development website. For the literature review part, the development of the home security system by using IoT application is the home security system which is combined with the IoT technology and other electronic components. The methodology of the system is regarded as the alert system, RFID system, and the digital lock system, along with the function of the element that used throughout the previous project study. For the previous project part, the first previous project is a security door control system using the RFID card. In this system, the organizing choosing to use the RFID technology is to evaluate the cost and the security implication, and is to indicate to control the door in a building with a relative low-cost design, user-friendly, and easy of the installation. For the second previous project, there are two levels of the application, which is RFID, password, and OTP. For the RFID reader will be read the tag and compare it with the store data. If matched, then the next level of the authentication will be proceeded. For the password and OTP, the password is entered will be compared with the store data. If matched, then the message of level 2 authenticated will be displayed. On the other hand, if fails to successfully unlock, then the alarm system will be activated. The third previous project, the title lock security system using the keypad and RFID. The 80 Mega 16 will be the microcontroller of this project. There are two layers of the security, which is first is RFID, the second is password. But before entering the password, there are two options, which is enter the password or changing the password. After the authentication, the door will be unlocked for the 30 seconds only, and then it will close the back to run the new process. For the fourth previous project, the RFID-based smart door lock system, the Arduino Uno is the microcontroller of this project. In this project, there contain two layers of the security lock and followed by an alert system. The alert system is used to send an alert message when the wrong tag or entering the wrong password. If two layers of the security lock are unlocked, then a confirmation message also will be sent out to inform the user. In this project, the RFID card is provided good authentication, but the keypad works as an extra layer of the security. For the fifth previous project, the title is the development of the prototype RFID GSM-based lock system. It's worked by the RFID read the tag, then the information will be displayed on the LCD. If successfully, then the code generated will be sent out. The user need to key in with the keypad. If successfully, then the door will be open. On the other hand, if the code generated key in is unsuccessfully, then the alert system will be activated. For the last previous project, the title is RFID-based Security Assessment Control System with the GSM technology. The 8800S51 will be microcontroller of this project. In this project, the RFID reader is used to read the tag and send the data that is present in the tag and compare the data present in the microcontroller. If the data present in the tag is equal to the data present in the microcontroller, then the DC motor will be on. For the GSM module, is used to send an alert message to the owner. There are table comparison for the previous project 1 until 6. After the previous project study, there are 3 monitoring interfaces will be carried out in this project. First is interface the Arduino Mega with the ESP32 CAN. For the 5 volts of the Arduino Mega is connected to the CAN board, and the ground pins of the Arduino Mega will be connected to the ground pin of the CAN board. The serial communication will be carried out, which is RX to RX, TX to TX. The reset pin of the Arduino will be connected to the ground pin, and the DO of the CAN board will be connected to the ground pin of its own to enable the ESP32 flash mode. After completing the program, the connection can be removed. For the second monitoring interface, the interface of the Arduino Mega with the SIM900A GSM module. There are 2 methods of the interfacing. First is without the software serial library or with the software serial library. For the first method, the wiring of the RX and the TX has to be disconnected when burning the program to the Arduino. To avoid the problem of the first method, for the second method, the connection will be RX to TX, TX to RX, and the ground to ground. For the last interfacing is interfacing the Arduino Mega with the RFID RC522. The connection of the RFID 522 with the Arduino Mega, SDA, SCK, MOSI, MISO, and the reset pin of the RFID is connected to the digital pin of the Arduino. And the ground to ground 3.3 volt to 3.3 volt. Conclusion of the literature review. The Arduino Mega is being selected as the microcontroller of this project. It will interface with the ESP32 CAN for the live streaming by a development website using the Wi-Fi features. SIM900A GSM module also be selected for the alert system and as the component for sending the alert message to the user through SMS. The RFID RC522 is selected for the RFID unlock system. In methodology, describe a detailed overview of the method used for this project, and based on the SDLE, 3 primary steps will be carried out. The project flowchart system block diagram system flowchart will be produced as the guideline for the project execution throughout the project process. The microcontroller code was created using the Arduino IDE, and the circuit diagram was produced using the Pro Tools. In PSM1, the layout of the home security system was carried out. List out the component needed, purchase the component, then the coding implementation will be carried out. After the coding implementation, the simulation in the Pro Tools will be carried out. Block diagram project. The power supply is connected to the microcontroller. For the digital input, the keypad is connected as a digital input. For the part of the unlocking, the RFID reader is connected for sending the data input. For the digital output, the LCD and the LED are connected for display the lock-unlock condition. Servo motor is connected for controlling the door, and the alert and notification part. The buzzer and the SIM900 AGSM module are connected for sending and notification the user. For the live streaming, ESP32 cam is connected using the Wi-Fi features. Flowchart project. First, initializing all the components. For the first task, the irrigator read the RFID tag. If successfully read, the green LED and LCD will be on. For the second task, entering the correct password, the green LED will be on, LCD will be displayed a welcome message. If entering the wrong password 3 times, the red LED and the buzzer will be activated. For the live streaming part, first is implemented the coding, get the IP address, and upload coding to the CAN board. The circuit diagram is carried out in the Produce 8 Professional. Due to some of the component library cannot be found, so only the Arduino Mega and some of the components are being simulated. From the diagram, the connection is being carried out. So the 3D layout is designed using the SketchUp platform. The dimension of the length is 161 cm. And the width is the 162 cm, for the height is the 50.5 cm. There is a list of the equipment. For the simulation, the element involved is Arduino Mega, LCD, 2 LED, buzzer, 2 virtual terminal, servo motor, keypad, battery, and a resistor. In the simulation, MYW19990415A is set as the valid tag, MYW19990415B is set as the invalid tag. Insert the tag into the RFID reader, then the RFID tag will be displayed the tag and show it is whether valid or invalid. When starting the simulation, the LCD displays a message of entering the password, and the red LED will be on. When entering the password, the second row of the LCD will display the symbol as the number that been keyed in. If the correct password is entered, the LCD will be displayed a welcome message, and the servo motor will start turning 180 degrees. The green LED will be on. On the other hand, the wrong password is entered, then the LED will be displayed wrong password. The first row, the second row will maximum attempted 3. And the red LED and the buzzer will be activated. For entering wrong password more than 3 times, the message of logout will be displayed on the LCD, and the red LED and buzzer will be activated. Notions of methodology. Main objectives succeed in this project will meet throughout the simulation build. Examine a home security system with a notification and alert system according to the simulation result. Some of the replacement library has been carried out, but also some of the failures such as failed to run the interfacing of the ESP32 cam and the GSM module. When doing the next hardware installation, the research on solving problem must be carried out to make sure that the operation is smooth and successfully. The implementation of software for this project is successfully to run and build. The expected result after running the simulation. First, interfacing the ESP32 cam with Arduino Mega can function well. The coding implementation of development a website can be uploaded to the CAN board, and it can successfully produce a development website for the live streaming. Next, for the interfacing the RFID with the Arduino Mega, the RFID reader can be read the data from the tag and send it to the microcontroller. For the last, interfacing the GSM module with the Arduino Mega, the alert message of the unauthorizations will be able to demonstrate. Next, there is reference for this project. And there's appendix A, B, and that's all my video presentation. Thank you.